Go ahead and open up to your 7.3 notes. We're going to do a quick refresher of the percent equation, which is in proportion form. Pause the video if you need to access your notes right now. This lesson was all about setting up a proportion to solve for either the part, the total, or the percent. Now, a reminder, if you were with us in 6th grade, we had to find the percent. We had to find the part. What's new for us in 7th grade is having to find the total. So when we did our 7.3 lesson, we talked about, do we have to use the proportion when we're finding the percent? No, you don't have to. Do we have to use the proportion when we're finding the part? No, we don't have to. Can you? Absolutely. Is it helpful or best to use the proportion when we're finding the total? Yes. So we're going to go through an example of each. Have a sheet of paper out as well so that you can do these with me. The best way to practice math is to actually do math problems. A box of candy has 25 pieces in all. If 13 of the pieces are cherry flavored, what's the percent of cherry flavored candies? What are we being asked to find here? What's the percent of cherry flavored candies? So we are needing to find the percent. That means we're going to have a variable right here in our proportion. What do we know? We know that there were 25 pieces in all. In all, that's telling me all together or total. That's going to represent my total amount. We know that 13 of the pieces are cherry flavored. We're looking for the percent of cherry flavored candies. So using the percent proportion, we could set it up like this. We know in our question it says what percent, so I'm going to put my variable there. I know 100 is always going to go underneath the percent. I know that my total is 25. And I know that my part in here represents 13. Again, when we did this lesson, we talked about when we have to find the percent, we can use our acronym, free Dr. Pepper. We can take the fraction to a percent by first changing it to a decimal and then to a percent. I'm going to show you both ways. When we have our proportion set up, we can use our cross products. So 13 times 100, that's going to give me 1,300. That's the same as x times 25, or 25x. If I want to solve for x, I'm going to divide both sides by 25. That's going to give me 1x, which I can just write as x. And 1,300 divided by 25, 1,300 divided by 25, there's my percent. So it would be 52%. So when we are using the proportion to solve for any of the missing pieces here in the proportion, we use our cross products. Now, since I did this back in 6th grade, I know that what I have right here is both parts of my fraction. I have the part and the total. So I can simply go from a fraction to a percent, where I'm going to go 13 and I'm going to divide it by 25. So if I go 13 divided by 25, there's my decimal, 52 hundredths. Now I'm at a decimal. I need to get to a percent. I'm going to move it to the right 2 times, and that's going to give me 52%. You'll see we got the answer, the same answer doing both ways. Again, in this problem, we were being asked to find the percent. Let's go ahead and let's look at the next problem. All right, here's our next refresher problem. It says Shannon's hair was 36 centimeters long. During the summer, she cut off 15% of her hair. How long was Shannon's hair after the haircut? What are we being asked to find here? How long her hair was after the haircut. We know that we have our percent in the problem. It's right here. She cut off 15% of her hair. So I know I'm not solving for the percent. And in my question, it doesn't say what percent. So whenever we're finding the part or the total, the tricky part is determining, am I finding the part or the total? So let's go back and let's look at what we have. Shannon's hair was 36 centimeters long. Well, wouldn't that represent the total length of her hair? Yeah, so we have our total value there. During the summer, she cut off 15% of her hair. We're taking a percent of her number. We know her hair was 36 centimeters long. So in this problem, we are finding the part. I'm going to show both ways where we're using the percent proportion, also known as percent equation, or using our skills from back in 6th grade. So if I'm going to set up my percent proportion, I know I have my percentage. So it's going to be 15. I plug in that for the percent, and it's always over 100 because 15 over 100 means 15%. I know I'm solving for the part because I know the total length of her hair, 36. Now we would use our cross products. 15 times 36 gives me 540. That's the same as x times 100, or 100x. So now, in order to get x by itself, which represents my part here, I'm going to divide both sides by 100, divide both sides by 100. That gives me 1x, which I can write as x, and 540 divided by 100 is going to be 5.4. And in this case, it's 5.4 centimeters. But what does that mean in this problem? Is that my final answer? No. How long was Shannon's hair after the haircut? We know that she cut off 15% of her hair. So this is how much she cut off. I need to answer how long is her hair now. What am I going to do with this 5.4 centimeters? I'm going to subtract it from the total length of her hair. So my final part to this problem is going to be 36 minus 5.4, which is going to give me 30.6 centimeters. That's how long her hair is now. Let's go ahead and let's do this how we did back in 6th grade, because this is really, when we're finding the part, we're taking a percent of a number. So we're going to take 15%, and whenever we're working with percentages, we have to calculate with them. We want them in that decimal form. So imagine where the decimal point is in 15% right there. We're going to back it up, the percent sign comes off. So 1500ths times 36. If I do that, 1500ths times 36, I see that I get the 5.4. That represents the centimeters she cut off. Now, I'm not done because the question doesn't ask how much did she cut off. It says how long was her hair. So again, I need to take my 5.4 centimeters that she cut off and subtract it from the length of her hair. 36 minus 5.4. We know that that gives us 30.6 centimeters. So we get the same answer. We solved it. The setup was just a little different. So in this case, we were finding the part. As you can probably already infer, this time we're going to be finding the total, and these ones tend to be the most challenging. Let's look at an example. Again, we're working on things from our 7.3 notes. We're looking at where we are comparing the part to a total, and that's the same as percent out of 100. These are two ratios that are equivalent. Do you remember what we call this? A proportion. During a race, Jenna jogged 84 minutes, and for the rest, she walked. If the time she jogged was 70% of the total time, how long did it take her to finish the race? So that's what we need to figure out, how long it took her to finish the race. We know that we're not going to be finding the percentage because it doesn't say what percent. We know that she jogged for 84 minutes, and we know that that 84 minutes was 70% of the total time. So if we think about it, 84 is 70% of the total time. Here's our setup. We are solving for the total. The best way to do that is in this percent proportion. Let's go ahead and let's use our cross products. 84 times 100, that's going to give me 8400. 70 times x, that's going to give me 70x. Remember, it's your known diagonal and then you divide by the other number, right? We end up dividing by 70. So 8400 divided by 70, that's going to leave me with 1x, which I can write as x. And 8400 divided by 70 is going to give me 120. What does that mean? Well, here my 84 was represented by minutes, so it's 120 minutes. Now, minutes is a smaller measurement. We could use a larger measurement to describe this, and it might help us comprehend it a little bit better. Let's put this, just for fun here, into hours. How many minutes are in an hour? 60. So if I go, how many groups of 60 can I pull out of 120? I'm going to go 120 divided by 60. I can see that that's 2 hours. So x is equal to 120 minutes or 2 hours. And this right here would be our final answer. So again, whenever you're finding the part, go ahead and use your percent of a number. Or you can set it up in the percent proportion when you're finding the part. When you're finding the percent, it's okay to just think, well, I have my fraction set up over here, so I'm just going to change that fraction to a percent. Or you can set it up in the percent proportion. When you're finding the total, the percent proportion is the best way to go.